Welcome, and thank you for attending my talk titled Effectiveness of Area 2 Value Legends and Grid Lines in Contiguous Area Cartograms. My name is Michael Gastner, and this research was conducted in collaboration with Kelvin Fung and Simon Perrault. We were supported by the Ministry of Education, Singapore. Using human subject experiments, we explored how visual aids like legends and grid lines affect how people interpret quantitative data in cartograms. Area cartograms are thematic maps where the size of geographic regions corresponds to a quantitative variable such as population. Several cartogram types exist. For example, regions may appear as separate polygons or as circles, scaled according to the mapping variable. However, geographic neighbors, such as Ohio and Kentucky, may not appear as neighbors in either non-contiguous or circular cartograms. In contrast, contiguous cartograms accurately display border segments, tripoints, quadrupoints, and higher-order multi-points shared between the depicted regions. For instance, unlike in a non-contiguous cartogram, Utah's common border with Nevada is visible in a contiguous cartogram. Moreover, a contiguous cartogram accurately displays the point where Utah meets Colorado, New Mexico, and Arizona. Our study primarily focused on contiguous cartograms, though our findings likely apply to other cartogram types as well. One of the challenges of reading area cartograms is that users must infer data values from areas, which is more difficult than estimating values from the lengths of simple geometric objects such as bars in bar plots. While bar plots can't reveal geographic relationships, we asked whether visual aids similar to those found in bar plots, such as axis ticks and grid lines, could help users estimate values in cartograms. In 1975, cartographer Borden Dent conducted experiments showing that magnitude estimation in cartograms improved when at least one key symbol at the low end of the value range was included. As an example, he presented a population cartogram of the eastern United States with a legend in the form of a square which corresponded to 1.5 million people. Building on Dent's findings, we introduced two additional features: grid lines, and an interactive selectable legend that allows users to choose a square size for reference. To demonstrate the selectable legend, let's look at a population cartogram of India. Participants could choose from 3 squares representing populations of 20, 50, and 100 million. Clicking on a square adjusted the grid lines on the cartogram to match the new reference size. Participants used a dual monitor setup. On one screen, they saw tasks such as estimating or comparing values between regions. On the other screen, they viewed the cartogram with or without visual aids. We recruited 44 participants, who first watched a 5-minute tutorial on cartograms and the experiment procedure. After practicing, they answered quantitative questions involving tasks such as estimating values, comparing regions, detecting temporal changes, clustering regions by similar values, and identifying the region with the highest value. These tasks used cartograms from 28 randomly selected countries. Participants could skip questions they found too difficult. Finally, they completed a questionnaire on their experience with the visual aids. When participants viewed cartograms without legends or grid lines, their estimates tended to center near the true values but with substantial variation. The addition of legends and grid lines reduced this variation but often led to underestimation. The presence of legends and grid lines did not speed up task completion and sometimes slowed it down. However, participants were more likely to finish tasks when visual aids were present. In the last part of the experiment, participants rated the aesthetics and usefulness of static legends, static grid lines, and selectable legends with grid lines, each on a 5-point Likert scale. Overall, the static legend received the lowest average ratings in 6 out of 7 categories, while the selectable legend with grid lines had the highest ratings. Without interactivity, participants found the grid lines somewhat helpful but not particularly elegant. In summary, we recommend always including a legend in area cartograms as it facilitates value retrieval, a task participants found nearly impossible without it. Many participants preferred larger legends because smaller ones required more effort to count how many legend squares fit into a region. Based on user choices, a legend covering about 5% of the total area appears optimal. While grid lines are less essential, we still recommend including them as they enhance engagement and boost user confidence, reflected in higher task completion rates. We are developing an online tool for creating and sharing area cartograms based on these findings. For more information, please visit our website at go-cart.io. Thank you for your attention.